Hello everyone. So welcome you to the second class of CSE 437 Data Science. And in this lecture specifically we will discuss about some inferential statistics, the concept of G score, standard scalar and hypothesis testing. So at first we will go through the inferential statistics and what does it mean and also how it is different from the descriptive statistics. Okay, then what is the difference between the inferential statistics and the descriptive statistics? So descriptive statistics, we all know about that. From the data, sometimes we need to produce the graph, sometimes we need to produce the histograms, and sometimes we need to just determine the mean of the values and median of the values. The descriptive statistics describe and summarize the data. So it just for the summarization, for example the chart or graph. So usually we plot the bar diagrams of our data, and those kind of statistics we call those on just the descriptive statistics. These are somehow also important because sometimes we need to know the mean and median, skewness and kurtosis values, all the descriptive statistics properties. Sometimes we need those properties also, and sometimes for inferential statistics we need to calculate the descriptive statistics too. So here the inferential statistics allows you to make predictions, that is the inferences from the data. Okay? And using the inferential statistics, and maybe without collecting the data from whole population, that is we just can take the sample populations and use the samples to make some predictions or infer something. So this kind of statistics are usually we call the inferential statistics. Here is an example, maybe it will clear the difference between the description and the inferential statistics. Like you stand in a mall and just ask a sample of 100 people whether they like shopping at YOLO or not. So this is one kind of the survey, just mini survey. Okay, you just ask the people in front of the mall and ask, okay, whether you like the shopping at YOLO, and they may answer just yes and no. So here the descriptive statistics is just you can make a bar chart for that, bar chart of yes and no answers. So this is just descriptive statistics. Sometimes this kind of statistics are necessary in data science. Sometimes you need to present like maybe how many males and how many females are in your study, what's the average of that. So using the bar or maybe pie diagram, pie chart. Okay, so those kind of things are just descriptive statistics things. And from this, what you can do, you can maybe infer something. So you can do some research on it, and the research like um, you could use your research to reason that around 75 to 80% of the population like shopping at YOLO. Okay, so here this is one form of your research. You can say that one form of your hypothesis, like okay, 75 to 80% of the population like shopping at YOLO. So you can infer or you can study this hypothesis also. Okay, so you just collect the sample of 100 people and you infer it for all peoples of the mob. And you can also test whether this hypothesis is right or wrong. Okay, that's the inferential statistics. Um, in social science domain of the data science, specifically in business domain, in social science study, in psychology, in psychiatry, uh, so many other fields, they need this kind of hypothesis testing, specifically the inferential statistics, to test their hypothesis and also some predictions. Okay, so here the inferential statistics specifically use the random sample of data. So random sample of data, that means maybe it's not possible or not convenient to collect the data from the all population, like here in case of our the, the COVID uh, spreading model. It is not possible to collect the samples from all the people. So what we can do, just who just visited any different hospitals, we have collected the samples from those people, and we can infer that okay, maybe 30% of the total population is infected in coronavirus. Okay, so this is just inferential statistics. Okay, so inferential statistics are concerned with making inference based on the relations we have found in sample, and from that we can infer it to the population, that means the total population. Then these things, that means the inferential statistics, we need to know how we can do that. Okay, how we can do that. There are many research papers specifically based on the inferential statistics. So to know the inferential statistics, to understand the inferential statistics, we need to know some of the statistical measurements also. Like here, the data distribution. I think you already familiar with the term the data distribution, maybe from your statistics course. So data distribution, we can say that we have data, we have collected data, we just collect the data. So if we can draw the histogram from the data, I think we know how to make that is the histogram for that. Maybe total amount of data, we can say total samples just 100, so we can make the 10 groups for that, and each and every groups, maybe we can say the first group will consist within the number within 0 to 10, and second group maybe 10 to 20, like this kind of interval. Okay, and then count how many numbers you can find here on 0 to 10 and 10 to 20, how many numbers you can find, and based on that, this is the binning. Okay, just uh, 10 bins, and you need to put the values in, count the values within the bin, and then you have to draw like this kind of histogram. So you can draw the histogram like this. This histogram will say something about your data. That means you can find the distribution of your data, like here in this case we can see that if your plot or the data or the the histogram of your data looks like this, then we can say that your data can be spread out more on left. Here we can see that that is within this range, most of the values are there. Okay, that means frequency of like this one is 25 and this one is 20. Okay, so that means in total number of data, most of the values are within this range. So in case of the distribution, we can say that this is the 50-50. So 50% is there and 50% is there. So this is the left and right. So we can see that this part we have many values in this part, and if the data distribution is this, looks like this, if your data distribution is look like this, then we can see that most of the values are in this side. Okay, and sometimes you can find that your data distribution is look like this one. You cannot say that my data is left aligned or right aligned. So it just gumble up. And sometimes you can find that your data distribution looks like this. So it is nearby the data distribution in nearly in centered manner. So this kind of distribution is necessary because we need to find out whether the data is left aligned, right aligned, or maybe the gumble up, or maybe just follow some standard distribution like maybe Gaussian distribution or Poisson distribution, binomial distribution. So there are several distributions. Specifically in data science and machine learning, we are very familiar with the normal distribution. So the normal distribution, usually we also call it the Gaussian distribution, Gauss distribution, Laplace-Gauss distribution. So in many names we call it the normal distribution. And this normal distribution is heavily used in this domain, data science and machine learning domain, for the scaling, for a standard scalar, and for the regularization. So for continuous value estimation. So many ways we can apply the normal distribution. So here we can see that what's the normal distribution? It's in probability theory. The normal distribution specifically, it's a continuous probability distribution. So continuous probability distribution. We know that the distribution are two types: continuous and the continuous and discrete. Okay, so the normal distribution is one of the continuous distribution. That's why we call it the probability density function. Okay, probability density function. And in discrete case we call it probability mass function. So here is the probability density function for normal distribution. This is the probability density function for normal distribution. And what we have to know here, we have to know the mean. That means we have to find out the mean of our data, and here is the standard deviation sigma, and sigma square the variance. Okay, the variance of the data. So we have to determine, or we have to know the mean and the variance of the data, and from that, if we can just put the value, any value of x here, any value of x, that is the data point, any data point, then it will tell us the probability that this kind of data will appear in that model. So that's why this is called the probability density function. The probability density function of normal distribution, specifically we can see that it looks like the bell curve. So data distribution, the standard and the perfect normal distribution is this one. Okay, so in case of the normal distribution, we can say that the mean, median, and the mode will be the same. Mean, median, and mode will be the same. That means it's just symmetry on the center. So that means 50% of the left side and 50% of the right side is the symmetry. So 50% of the values less than the mean, and 50% of the mean values are greater than the mean in case of normal distribution. Then we will discuss today about the normal distribution and the standard scalar. Specifically, we used in data science for scaling the values. So here is the Python code for normal distribution. Like here, you can say that here is the mean. If the mean is 6 and standard deviation, you can input like a standard deviation is 2, and we want to find the normal distribution curve for that. So we can generate some values, like maybe from that is the x values, the values, the data values. Okay, so here range from 0 to 15, a range from 0 to 15, that means the values will generate within this range 0 to 15, and with an equal space of 0.1, that means 0.1 with an equal space, incremental space of 0.1. So then it will generate the values like this for x, like 0, 1, 2, 0 0.01, 0 0.02, like this. Okay, and if we can put this x here in this equation, we already know this equation, specifically this equation here, 1 by square root of 2 pi sigma square and e to the power minus of x minus mu, that is the mean square, divided by 2 sigma square. Okay, so this equation here, 1 by, this is numpy square root 2 numpy pi, here is ss, that is the s and s, standard deviation, and here is the e. Okay, and numpy dot exp e, and x, the value here generated, maybe the first value we can say the 0. If we put the 0 here, and this is the u, that is the mu, here mean, that means 6, and s square here is the divided by 2 sigma square, s square. Okay, so you will get the probability of that value. And if we plot this one, x and y, the x values and y values, we will find this graph, and we can see that this is the bell shaped, and probability density values will be this. That's why here is the plotting, and the plotting with line, and here is the title Gaussian PDF. Here is the Gaussian PDF. Okay, mu and sigma values, and then x labels here is defined, and x with font size 15, so here is the x font size 15, and y label, here is the y label is probability density, it is written the probability density with the font size 15. Okay, and then show the plot. Okay, so we will find the Gaussian distribution normal curve if we just define this, the mean and standard deviation. So here we can see that this is the mean, the center. Okay, center of this, and other values are just around the center. Okay, so this is the code for Python code for normal distribution. So some interesting properties of normal distribution we have to know, and that's why normal distribution is so popular. Here is this, we can see that the in case of the normal distribution, in any mean, for any mean, maybe the mean is 6, mean is 2, mean is 5, whatever mean you define, the values will be 68% values will be in this just only within one standard deviation, within this range, one standard deviation. So 60% of values will be in this just only around the center, within one standard deviation. One standard deviation means there is the positive and negative one. 50% values will be in this side, and 50% of values will be in this side. That is, we can say that 68, so 19% will be in this side, and 19% will be in this side. Okay, so here we can not 19, it is it 19?
Sir, shouldn't it be 34%?
Hello?
Yes, sir.
Sir, 34 on each side.
Yeah, 34% of in each side. Okay, I will, why I am saying this, I'll let you know later. Okay, so 34% in each side. And then we can say that here is the 95%. 95% will be within just two standard deviations. Within just two standard deviations, 95% values will be centered on this. Okay, and 99.7% will be in three standard deviations. And again, the symmetric, that means 50% will be in one side, left side, and 50% will be in right side. Okay, so we will see most granular form of this later. So now just first the use of this, that is the normal distribution. We can see some example, like the 95% of the students at school are between 1.1 meter and 1.7 meter tall. So it is mentioned that 95% of the students at school are between, in this range, 1.1 meter and 1.7 meter tall. So if we assume that the 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 student height, those are just normally distributed. So can we find the mean and standard deviation? So here from this just only information that 95% of the students at the school are between this 1.1 meter and 1.7 meter tall. With this information, if the data follows just only normal distribution, you can assume, then can we find the mean and standard deviation from this information? So we can see that here is the 95%. That means we can say this is the 95%, and 95% students at school are between this range, that is 1.1 meter to 1.7 meter. So here is this, you can see that the 1.1 meter and 1.7 meter within this range. So how can we determine the mean? We know that in case of the normal distribution, normally distributed data, mean will be the center. Okay, so that means we can say that 1.1 meter plus 1.7 meter, just if we divide it by 2, then we will find the mean. So that means without computing the whole data, without sum up the whole data, just only we can calculate from this information. Okay, so mean will be 1.4 meter, and then 95% here. Another one is standard deviation. Can we find the standard deviation for this? So here we can see that the 95%, that means that is how many standard deviations are here. We can say that this is one, this is one, this is another one, and this is another one. So we can say that total we have, that is 4 standard deviations. So the difference, we can say that the difference here, the difference is 1.7, 1.7 minus of, here is the 1.1, 1.1. So within this difference value, within this value, we have 4 standard deviations. So we can divide it by just 4, and you will find that the standard deviation will be 0.15 meter. So that for this information, and if the data is normally distributed, then we can determine the mean and standard deviation for that, and this is also necessary for other purposes. Okay, any question please?
স্যার আমার একটা কোশ্চেন ছিল স্যার,
আমরা যে স্যার স্ট্যান্ডার্ড ডিভিয়েশন স্যার এখানে 4 বের করেছি।
why 4?
স্যার আমরা যে স্ট্যান্ডার্ড ডিভিয়েশন 4 বের করেছি স্যার, এটা তো স্যার আমাদের কোশ্চেনের সাথে কোনোভাবে রিলেটেড না স্যার, এটা তো আমরা গ্রাফ দেখে বের করছি না।
Yeah, that's why the properties of the standard normal distribution we have to know the properties. Okay, this is the property, standard properties, that is 68% will be within the one standard deviation, 95% will be within two standard deviation, and 99.7% will be in the three standard deviation. That's why we need to know the properties of normal distribution.
স্যার এই যে স্ট্যান্ডার্ড ডিভিয়েশনের যে স্যার যে 4 বা 2 এই যে এলিমেন্টগুলো স্যার, এগুলো কি আমাদেরকে কোশ্চেনে দেওয়া থাকবে? এই এলিমেন্টগুলো না
স্পেসিফিক্যালি কোশ্চেনে দেওয়া থাকবে এরকম হচ্ছে না, কারণ হচ্ছে যে আমাদের যদি মোস্ট গ্র্যানুলার ফর্মে থাকে যে তাহলে হয়তো কোশ্চেনে দেওয়া থাকবে, কিন্তু যদি আমাদের 95% বা হচ্ছে 68%, দোজ আর ভেরি পপুলার অ্যাকচুয়ালি নাম্বার, সেজন্য এটা কোশ্চেনে দেওয়া নাও থাকতে পারে আর কি। বুঝতে পারছো?
জি স্যার।
ওকে, specifically in statistics these are very basic one. Okay, that means all the students should know just these properties. Okay.